All missions must come to an end. But where do the spacecraft go? In 2023 alone, 2,845 new objects were launched into space. That's more than ever before. However, it also saw a record number of satellites re-enter Earth's atmosphere. The rising number of re-entries is a good thing. Disposing of satellites efficiently is one of the most important things for keeping low Earth orbits safe. By planning the re-entry of satellites, we're not just ending a mission, we're advancing the science of satellite re-entries and contributing to a zero-debris future. Let's go back to the year 2000, a time when boy bands in Brittany were dominating the pop charts, the mobile phone was practically new, and our Cluster mission was launched. Cluster studied perhaps the one thing that makes Earth a unique habitable world where life can thrive. Its powerful magnetic shield, the magnetosphere. Like an enormous umbrella, the magnetosphere protects us from most of the driving rain of particles that the sun relentlessly sends in our direction. But gusts of this solar wind can still push through, sending bursts of energetic particles cascading towards Earth's surface. The most common result is the northern and southern lights, or auroras, but more rarely, these particles can cut our power supplies, disrupt radio communications, or damage satellites. The mission, consisting of 4 identical satellites, Roomba, Salsa, Samba and Tango, otherwise known as Cluster 1, 2, 3 and 4, was only expected to last for 2 years. Yet, against all odds, it has provided us with invaluable insights for over 2 decades, contributing to more than 3,600 scientific papers, and allowed scientists to observe 2 solar activity cycles. But now, as fuel runs low, we are preparing to re-enter these satellites. This isn't just a routine deorbit, it's a carefully planned, targeted re-entry, starting with the satellite Salsa. Most satellites re-enter Earth's atmosphere in an uncontrolled manner. They are switched off at the end of their mission and left to gradually give in to Earth's gravity and burn up in the atmosphere. There is good news though. We are developing new techniques to safely re-enter satellites that were not initially designed for it. This lets operators remove hardware for space more quickly and with more knowledge about when and where it re-enters Earth's atmosphere. Cluster's re-entry will be the first time that a safe re-entry technique, called a targeted re-entry, has been attempted. Our expert teams are taking advantage of Salsa's uniquely large orbit around Earth to plan the spacecraft's descent into the Earth's atmosphere. Due to the satellite's big orbit and the influence of the Sun and Moon's gravity on the spacecraft, the closest point to Earth can vary by dozens of kilometres from one orbit to the next. This creates big jumps in the altitude, which we can use to target when Salsa crosses the threshold where satellites burn up, about 80 kilometres above the surface. This allows us to precisely predict when and where Salsa finally re-enters the atmosphere, with any fragments safely splashing down over a remote stretch of ocean. Salsa's re-entry is just the beginning of the end for Cluster. The remaining 3 satellites will be placed in caretaker mode, awaiting their turn. Roomba is scheduled to re-enter in 2025, followed by Samba and Tango in 2026. Each re-entry will be targeted to occur over remote regions in the South Pacific, far from any densely populated areas. Why should we deorbit satellites? The space around Earth is littered with defunct satellites, spent rocket components, and other pieces of space debris that represent a hazardous environment for current and future space missions. We have long played a leading role in the implementation of space debris mitigation measures. In 2024, we deorbited our ERS-2 satellite, reducing its orbital lifetime from 200 years to under 19 years. In 2023, our teams guided the Aeolus satellites to burn up over uninhabited regions in the Atlantic Ocean and Antarctica. Even though the satellite was designed in the late 1990s with no intention to control it in this way, showing that just because an older satellite wasn't designed to be controlled during its descent doesn't mean it's impossible to do so. But why does clusters re-entry matter so much? For us, it's a chance to study re-entries under controlled conditions, something that has rarely been done before. Clusters re-entry is also special because it consists of 4 identical satellites. Therefore, we have 4 opportunities to collect valuable data by safely re-entering the same satellite under slightly different circumstances. We can observe what difference it makes as they re-enter at 4 different angles and speeds, and under 4 different sets of atmospheric conditions. By observing clusters' descent, scientists hope to improve our understanding of how satellites break apart during re-entry, which is critical for designing safer, zero-debris spacecraft in the future. Since this is a targeted re-entry, we know its location precisely enough that we can send a plane out to observe it from below. This is a rare opportunity that will provide real-time data that can't be gathered from the ground, helping to validate computer models and improve re-entry techniques for future missions. The end of cluster marks the conclusion of a remarkable era of space science, but it also signals the beginning of a new chapter in our understanding of satellite re-entries and space debris management. As SALSA makes its final descent, it's not just the end of a mission, it's a legacy that will inform the future of space exploration for years to come.